Hi viewers, welcome to LMS Solution. Today we are going to see about demand side management in grid connected energy storage system using deep neural network. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for a notification about upcoming videos. Straight away we go to see about implementation of this logic in the MATLAB. So this is the simulation model for grid connected energy storage system. Okay, so here you can see that. So this is known as grid. So grid having 154 megawatt power with a voltage of 34.5 kilovolt, and then it going to be stepped down to 400 volt. So from 34.5 kilovolt to 400 volt, and then it's going to be connected with the grid connected battery. Okay, so in between that grid and the grid connected battery, so we have different kind of loads. Okay, so you consider this is load one. Okay, the load one consists of two kind of loads. So one is residential load and a commercial load, and then this two going to be considered a load two. So this is also has a residential load and a commercial load, and then load number three. So this is also consist of residential load and commercial load, and then fourth load nothing but we have only residential load, and then fifth load only have the residential load. Okay, so this load data is taken from some local station. So the detail presented here. Here you can see that, yeah, the residential load data for 24 hours. So for residential load 1, 2, 3, 4, and 5. So data is taken for every 30 minutes. So totally the data having for 24 hours. Okay. So based upon the time of the day. Okay. So the each 30 second the load and the residential section going to be vary. Okay. So this is a residential load data. And then you can see here commercial load data. So this is a commercial load data, or we can call it as industrial load, or store the shop relevant load, right? So this load, the data is given for 24 hours for every 30 minutes. So are the changes in the commercial load 1, 2, and 3. Okay. So based upon this data, so we are generating that load profile here. So you can see that. So this is load profile data for different timings for 24 hours. So this is that load data is going to be loaded here. So it's automatically adjust the load profile here. Okay. So in each residential load and commercial load, so we have created load profile. So based upon that Excel sheet data, so we have created here. Okay. So this load going to be shared by means of grid as well as grid connected battery. So next we got to see about what inside that the grid connected battery. Okay. So this is a block inside the grid connected battery. So having battery with the DC link, and then inverter, grid inverter, and then battery having a battery control. So that means battery control used to control the charging and recharging process of the battery, and then inverter control, so to control the grid inverter for synchronization with the grid. Okay, so this is a block inside that block, the inside that grid connected battery system. Okay, so here that the load profile, so the power sharing of the grid and the load sharing of that grid connected battery. So here going to be controlled by means of neural network. Okay, so the neural network going to be receive two inputs. So one is time of the day, so another one is SOC. Okay, so based upon that the time of the day and the SOC level of the battery, so neural network going to be provide some power, required power, uh, that means the battery. So how much power battery going to be shared to that grid connected system. So that command going to be generated by means of this neural network. So based upon the two input, time of the day and SOC, state of charge of the battery. Okay, so that going to be given to that input for a grid connected battery. So if that command will be positive, then the battery going to be supply the power to the grid connected system. So based upon that power requirement, so how much power is given by means of neural network, that means it is positive, then it going to supply the power to the grid. Is suppose the output from the neural network, the command output will be negative, so then it going to take the energy from the grid to charge the battery. Okay, so this is a basic concept in the demand side management. So normally the battery normally used to for uh, clip the power of during that peak hours. That means so we need to get out the power generation during that peak hours by means of some special arrangement. So that process is going to be done by means of this battery system. Okay, so that means we are going to conserve the energy of grid power generation by means of that energy storage elements. Okay, so that we are going to clip the peak hours generation. Okay, by means of this energy storage system. Okay, so before that we have to see about that without neural network. So what was that profile of load as well as sharing of that power from grid and battery. Okay, we will uh, check that one simulation. So for that I'm going to open that model. Yeah, so this is grid system with they have some load, right? So you can see that output of the system. So now the bat is not connected with the grid system. So only grid going to be supply the power to the load. Okay. So we will wait for 24 seconds. So this is a variation of the power sharing of grid, and then this is battery power because the battery is not connected with the system. So the battery power is always zero here. So this is a load profile for load 1, and this is load 2, load 3, and load 4, load 5, and then finally this is nothing but the total load profile of the different kind of loads. So totally we have uh, there are 5 load, right? So this total power of the load, right? You can see the graph. This will be same like the grid power. That means the power will be shared by the grid power is equal to power to the load, right? So in this you can see that this portion from time 10 to that 18 going to be considered as peak hours. Okay, and then from 0 to 10 and 18 to 24 going to be considered as off peak hours. So we need to cut down the power generation during that peak hours. So that can be possible when we are going to use a energy storage system to supply the power during that peak hours. Okay, so that means we are going to clip that power generation during that peak hours. Okay, by means of that energy storage element. And same time during off peak hours. Okay, during off peak hours you have to that means charge the battery or charge the energy storage element by means of grid system during off peak hours. So this is going to be implemented in that simulation. So that means here also you are going to manage the demand side. Load demand also going to be managed, as well as the generation portion also going to be controlled by means of that energy storage system. Okay, so how it going to be implemented by means of a neural network when we are going to connect that battery with the grid system. Okay, so that going to be explained next. Okay, so already I told, right, the neural network. Okay, that neural network going to be receive two input. So one is time of the day and then SOC of the battery, and then it will going to provide command power to that battery for charging or discharging condition. So that can be come from that neural network. Okay, so the main objective here we need to implement neural network, right, for implementing that concept. Okay, so for that we need to generate some input output data. So the input data nothing but the time of the day and SOC, and the output data nothing but command input for that battery system. Okay, so for that I have implemented one code for generating of the data. So based upon time of the day. Okay, that means I'm going to generate 1,000 data. Okay, for to train the neural network. Okay, 1,000 data I'm going to generate so 10,000 data, and then I'm going to randomly generating the time of the day by using this equation. Okay, by using this equation, and then SOC also randomly generated by means of this equation. So after that I'm going to fix the command for battery. Okay, based upon the time. So here I'm going to check the time, whether the time is less than greater than 0 or less than 10. So this the time period from 0 to 10, right, known as off peak period, right. So here we need to charge the battery. So for that I'm going to check the time of the day, whether it's in between 0 to 10, and also I'm going to check the SOC level. If SOC level is less than 50, so we need to charge the battery. So for that I'm going to provide negative command from neural network. Okay, and then I'm going to check the data. So I'll check the time of the day. Okay, whether it is in between 10 to 12, right. So during the time battery need to supply the power in the rising order. Okay, so for that I'm going to check the time in between 10 to 12, and also I'm going to check the SOC level. So if SOC level is greater than 50, so I'm going to provide positive command to that battery connected system to supply the power to the grid. Okay, and then we can see next step I'm going to check the time in between 12 to 18. So here the battery going to be supply should be in decreasing order. Okay, like that. Okay, so further I'm going to check the time between 12 to 18, and also I'm going to check the SOC level, whether it is greater than 50 or less than 50. If it is greater than 50, I'm going to give positive command, linear decreasing command to that battery system by means of this equation. After that I'm going to check the time, uh, whether it is between 18 to 24. It is known as half peak period. So this is from 10 to 8 is known as peak period, right. So from 18 to 24 known as half peak period. and also I'm going to check the SOC level whether it is less than 50. Then I'm going to give the active command to charge the battery. Okay, so same way, next we also check the same time condition, but I'm going to check the SOC level whether it's greater than 50 or less than 50. So based upon that command, I'm going to change the output of the neural network. Okay, so in order to frame that neural network, we must generate data, input output data. So these are the and this value is going to be considered input data. T and SOC is going to be considered as a input data. The O going to be considered as output data. So O nothing but the command going to be given to the grid connected bed. Okay. So finally, I'm going to make the data. So here data one. So it should be in matrix form. Okay. And then this is output. That means output for the neural network. That means output data. Okay. So next I'm going to simulate this one. So after simulating this one, so you will get data here, right? You can see that output data and then data one nothing but input data. Okay, so next process we need to type so we need to train this data into the neural network. So for that, just go to type NN start. Okay, after that this window will be open. So just go to click fitting application, right? So after clicking that one, just go to click next and then select the input data. So here I'm going to select input data is data 1 and then output data is O, and then click matrix flow, okay, to match the data, right? So after clicking that one, just click this next button, and then here you can see the number of training and testing data samples. Okay, so next you go to click next, and then you can specify the number of hidden neurons in between input and output layer. Okay, so here I'm going to use a default value 10. Okay, after that I'm going to click next. So here you can select any algorithm, so LM or BR or SC algorithm. Okay, so I'm going to use second one and then train the network. It is training the neural network based upon that input and output data. Okay, so after that, just to click plot regression, right? In order to check the data whether the data is fitted with the input output data. So for that you have to click plot regression. So here you can see that the R value is around 0.9, right, for training, testing and all. So it's nearer to 1. So if R is nearer to 1, so won't worry about that. So the trained neural network is fitted with the input output data. So just go to uh, close this one and then click next button. Okay, and then click next. So after that, this model normally deployed in that Simulink model. So for that, I'm going to click Simulink diagram. So here you will get the trained neural network, right? Just go to copy this model. Okay, copy that model and then paste it here. Okay, so this trained neural network going to be receive two input: time of the day SOC and then command signal for that grid connected battery. Okay, so the neural network going to be act based upon that and time of the day and the SOC level. So it going to be discharge the grid connected battery accordingly. And also already told, right, that peak hour power generation going to be cut out by means of this energy storage system, and also the off peak hour going to be filled by means of the during charging of that battery. Okay, so let me see the response of this model. So model start simulated. Okay, So it will take some time to complete the 24 hours. Okay, so we will wait up to completing the simulation. Almost comes to end. Now you can see that during the top peak hours, right? So battery, the power will be negative. That means battery goes to charging mode. Okay, during peak hours, right, from 10 to 8 a.m., the power of that battery increases gradually to maximum, some maximum level, and then decrease gradually. Okay, after 18, okay, the system goes to off peak hours. So the battery power is negative. That means it goes to charging mode condition. And also you can see that during the peak hours, the power generation is somewhat uh, clipped out, right? During that peak hours. Okay. So by means of this energy storage along with the neural network, demand side also, that means demand load power also meet out uh, successfully, as well as the power generation during peak hours also going to be clipped out by means of this energy storage along with the neural network. So next I'm going to show you the comparison between the normal and the, so this is the normal, that means grid going to be supply the power to the load without having any uh, control, right? Without any energy storage system in the system. Okay. So here you can see that. So it will go up to nearly 160 kilowatts, right? But this portion, right? This portion going to be clipped out by means of that battery. Okay. So by means of this neural network, demand side management concept. Okay. So this is a result of that demand side management system in grid connected energy storage system by using neural network. Thank you for watching our videos. Kindly subscribe our channel and also click bell icon for upcoming videos, notification about upcoming videos. Thank you so much.